Welcome to the Explainer. Okay, let's just dive right into this. Today, we're unpacking a really fascinating and honestly highly lucrative area of ethical hacking. We're looking at how a single tiny keystroke, just one unsanitized character, can cause absolutely massive damage to global companies. We're talking about SQL injection, a concept that sits at the very heart of web security. To understand the threat here, think back to a simple fill-in-the-blank test you took in school. The teacher gives you a sentence with an empty box, and you're supposed to write a word inside it. But what if, instead of just writing a word inside that box, you wrote a completely new set of instructions outside the box that literally overrode the entire test? That is exactly what hackers do with input fields on websites. By escaping the intended boundaries, they can rewrite the rules of the database itself. So here is our roadmap for today. We'll start with database basics, then escalate to blind injections with Yahoo Sports. After that, we'll explore time-based attacks against Uber, look at how automated defenses were bypassed in Drupal, and finally, wrap up with the ultimate fix, prepared statements.
Okay, Section 1, Database Basics and SQLi.
So, SQL Injection, or SQLi. This happens when user input isn't properly cleaned or sanitized before it gets sent to the database. This little oversight allows an attacker to manipulate the back-end query. And because a successful SQI can let a hacker extract private user data, bypass logins entirely, or even create their own admin accounts, it's considered a devastating bug. Unsurprisingly, it's highly rewarded in the ethical hacking community. Before we break into a database, we kind of need to know what it looks like. Databases store information in a collection of tables. Now, these tables are structured with columns, which represent specific data categories, like a name or a password, and rows, where each row is a single distinct record. When an attacker executes a SQL injection, this architecture right here is exactly what they are trying to access and extract. Normally, a database query wants to select records from a user's table only if the name and password perfectly match the input. But an attacker can just input an apostrophe after test, which effectively closes the expected input box early. Then they add or 1 equals 1. Since 1 always equals 1, the database evaluates this as true, completely bypassing the password requirement. No password? No problem. The semicolon ends the statement, and those 2 dashes at the end, they tell the database to treat the rest of the original code, including the password check, as a comment, ignoring it entirely. It's a brilliantly simple trick. Moving on to Section 2. Blind SQL Yahoo Sports. Now, often, a website won't just neatly print out database errors or hand over the hidden rows you asked for. The direct results are completely invisible to the user. This creates a scenario we call a blind SQL injection. You can send the malicious query, sure, but you can't actually see the direct output on the web page. So, the crucial question is, how do you steal data you literally can't see? Well, hackers use Boolean logic. It's like playing a game of 20 questions with the server. They inject a statement that asks the database a true or false question. If the statement is true, the page loads normally. If it's false, maybe the page drops a tiny bit of content, or maybe it returns 0 results. By asking hundreds of these true/false questions, an attacker can infer exactly what is hidden inside the database, character by character. This exact true-false technique earned hacker Stefano Vetterazzi a cool $3,705 bounty from Yahoo Sports. He noticed that just adding 2 dashes to a URL parameter changed the list of NFL players displayed on the screen. Knowing he had an injection point, he asked the database a Boolean question. Does your database version start with the number 5? The query returned no players, meaning the answer was false. By simply observing these really subtle true-false page changes, he proved he could extract sensitive database info without ever seeing the direct output. Section 3. Time-based attacks. Uber. So what happens when the page doesn't change at all? Hacker Orange Tie was looking at an encoded Uber unsubscribe email link. He decoded it, injected this tiny little snippet of text, and sleep 12 equals 1, re-encoded it, and clicked the link. The website took exactly 12 seconds to load. Why? Because the database evaluated the sleep 12 command and literally paused its operations for 12 seconds before returning a result. This confirmed a massive vulnerability. To prove the impact without seeing any data on screen, Tsai wrote an automated Python script. The script would ask the database, is the first letter of the database username an A? If the answer was false, the server responded instantly.
If it was true, the server slept for 12 seconds. By measuring the time it took the server to respond, his script meticulously brute forced the entire database username and hostname, character by character, completely in the dark. Uber awarded a $4,000 bounty for this really ingenious time-based blind SQI. And honestly, it was well-deserved. If a malicious attacker had found this instead of an ethical hacker, they could have used the exact same automated time delay script to slowly extract Uber's entire customer email database from that third-party server. Section 4. Bypassing defenses. Drupal. This is a really critical question. Developers often rely entirely on built-in database APIs to keep their queries safe. But what happens if the defense mechanism itself is actually flawed? This is exactly what happened to Drupal, which is a massive content management system. Drupal's database API actually had built-in security to prevent SQL injection. But an ethical hacker named Stefan Horst noticed a flaw in how Drupal processed the in clause, which is used to check lists of items. Instead of passing a standard parameter, an attacker could manipulate the URL to send an array, like name bracket 0 bracket equals user. Because Drupal's API wasn't expecting the key of the array to be malicious, an attacker could inject a SQL comment right into the array key, breaking the internal template creation completely. The impact here was absolutely devastating. Because PHP data objects support executing multiple queries at once, an attacker wasn't just limited to viewing data. They could append insert statements right to the query. This meant any completely anonymous user on the internet could execute a command to silently insert a brand new administrative account into the database. We're talking about a complete site takeover. For finding this underlying logic flaw in Drupal core's database API before it could be abused in the wild, the bounty paid was $3,000. It triggered an urgent security update because literally every unpatched Drupal site on the internet was completely vulnerable to this specific array bypass. Section 5. The fix. Prepared statements. So how do we stop all of this? The golden rule of database security is using prepared statements. A prepared statement treats the SQL query not as a dynamic piece of code, but as a rigid template with specific placeholders. Let's break that down. With a dynamic query, unsanitized input just gets glued right into the code. This confuses the database about what is an instruction and what is just data. But with a prepared statement, the database compiles the query template first. Then it drops the user input strictly into the variable placeholders. So even if an attacker types or1 equals 1, the database just views it as a literal string of text to search for rather than an executable command. It completely neutralizes the threat of dynamic query manipulation. I'll leave you with this thought. Web frameworks offer great protections, but as we saw with Drupal, even built-in defenses can have blind spots if data is passed in unexpected ways. If your query logic is a locked door, are you making sure the hinges, the APIs, and the input structures themselves are actually secure? It really challenges you to look beyond basic web defenses. Thanks for joining me on this explainer, and keep questioning how the systems around you are built.